Hi, today we're going to talk about prime factorization and greatest common factor, or GCF. First thing that we're going to talk about is what is a prime number? A prime number is a number whose only factors are one in itself. A composite number is made up of other factors, another way of getting there. So it has more than two factors, the two being one in itself. So a composite number, if you can think of any other number that can be a factor or divide into it evenly, then it's a composite number. So look at example 1. Tell whether each number is prime or composite. Well, the number 23 is prime. Its only factors are 1 and 23. However, 129, well, it's not even. It doesn't end in a 5 or a 0. So then I'm going to go to my divisibility rules for 3. Well, 1 plus 2 is 3 plus 9 is 12. And 12 is divisible by 3. Therefore, this number is a composite number. 3 is a factor. Okay, so tell which numbers from 10 to 20 are prime and which are composite. Well, in order to approach this problem, let's first list those factors out. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Not those factors out. Let's list those numbers out. What are the numbers from 10 to 20? Now, it's easier to go through the list first and find your prime numbers. Prime numbers only have 1 in itself. Well, 10, no, I know that's 2 times 5. 11 is prime. 12, I know we have 3 times 4 and 2 times 6. Now, 13 is only 1 and 13. To get to 14, I know I can do 2 times 7. 15, 3 times 5. 16, 8 times 2. 17 is prime. 18, I have 6 times 3. 19 is prime. So my prime numbers are 11, 13, 17, and 19, the 4 that I circled. My composite numbers are everything that's left: 10, 12, 14, 15, 16, 18, and 20. Even though I said for 18, I think I said 3 times 6, 9 times 2, as long as you can find any other combination, all right? Prime factorization, we call these factor trees. And you keep breaking them down until you only have prime numbers left. That's why it's called prime factorization. We factor till we're prime. So take a look at example 2. Large number like 825. Well, it ends in a 5. I'm going to start there with that divisibility rule. And yes, I do have to go over here on the side and do my long division, 5 into 825. But I do know because of my rule that it will work. So I come out with 5 times 165. 165 is not prime. Why? Because it ends in 5 again. So I know 5 is a factor. I do it again and I find out 5 times 33. 33 is not prime. It is 3 times 11. When I am done, I go through and I circle all of my prime numbers. Now I want to write it in increasing order, all my factors, which I have 5, 5, 3, and 11. I take all my factors and I write them in increasing order, my smallest number first. 3 times 5 times 5 times 11, and then I use exponents, 3 times 5 squared. And that's how you do it. Let's try a couple. 72. Okay, it's even, it ends in a 2. I could do 2 times 36. 8 times 9, the better you are, the quicker you are with your math facts, the easier this actually is going to be. This is 2 times 18. This is 2 times 9. This is 3 times 3. Now my factors are the ends of my branches. So I have 2 times 2 times 2 times 3 times 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That gives me 2 to the third times 3 squared. If I chose 8 times 9, it breaks down differently, but you end up with the same factors. Can't get a different one. Okay, look at number 3. 150. Oh, that's a red flag. It ends in a 0. That means 10's a factor. 10 times 15. The closer these factors are together, the shorter it's going to be as you're going down. The further they are apart, the longer one side is going to be. All right, so this is going to be 2 times 5, 3 times 5, prime, 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 prime. I'm done. Write it in order from least to greatest. 2 times 3 times 5 times 5. Write it using exponents. 2 times 3 times 5 squared. And look at the number 4, 236. I'm going to say 2. All right. That's going to be 1 half of 36 is 18. So 2 and 118. Then I'm going to say, okay, this is even, so I have 2 and 59. And that's all that I can do. So this is going to be 2 squared times 59. Okay. Let's take a look here. Finding the greatest common factor. Example 3. Find the GCF of each pair of numbers. What does that mean? A greatest common factor means there will be common factors between the numbers, but the greatest common factor is the largest one that's common in both numbers. So let's start and just use the factor tree. So now you're going to do it. If you have 2 numbers, you do 2 trees. If you have 3 numbers, 3 trees, and so on. So 40 is 4 times 10. 10 is 2 times 5, and 4 is 2 times 2. I've circled all of those because they are prime numbers. And then I'm left with 2 times 2 times 2 times 5. And 60 is going to be 6 times 10, or 6 is 2 times 3, and 10 is 2 times 5, which comes out to be 2 times 2 times 3 times 5. So I've written them out that way. I do not use exponents. So let me write that on here. Do not use exponents. I don't think it's easier at all. And there'll be a reason why when I get to LCM. Okay. Do not use exponents for GCF. So now what I do, I've got it listed out. Take out a 2, it's in both. Can I take out another 2? Yes, I can. There it is. Can I take out another 2? No, it's not here. Can I take out a 3? No, it's not here. Can I take out a 5? Yes, I can. Here. 2 times 2 is 4 times 5. My greatest common factor is 20. Look at letter B. The difference now is there's variables. Okay, so you're going to factor the 6, 2 times 3, and then you're going to write this in expanded form. So 2 times 3, a to the third is a times b. 4 is just simple, that's 2 times 2. A squared is a times b. And again, I can take out a 2. I can't take out another 2 or 3. I can take out 2 a's from here, 2 e's from here. That's where these are coming from. And then I can take out a b. Now let's put it all back together. 2a squared b. And let's try a couple. Use prime factorization to find the GCF. 8 and 20. 2 times 4, 2 times 2. This is 2 times 10. I could have chosen 4 times 5. This is 2 times 5. So this is 2 times 2 times 2. Notice I am not using exponents right now. My GCF is going to be, I can take out a 2, another 2, and that's it. My GCF is 4. Look over here. This is 3 times 5, and those are prime numbers. So now I'm going to have 3 times 5 times m times m times n. And 45 is going to be 3 times 15. 15 is 3 times 5. So this is 3 times 3 times 5 times m. Now my GCF here, I can take out a 3, I can take out a 5, and I can take out an m. 15m. And that's it. Okay? You can also be asked for something like this if you have band members or something in 3 different groups, and they have to have the same number of people in each. That would be a typical example of trying to find a GCF. What's the common number that they all can break up into? All right, good luck.